It's amazing when, with proper planning, inside of 24 hours, how much things you can put out. With quantum computing, which is still, even though we've been working at it for so long, seemingly, it's still at its infancy. Still, no one knows what will come out of it at the end, because it's a very noisy environment.
Iterating tactically, that's to solve both your machine learning problems as well as your business problems, right?
Correct.
Greg, welcome to the program. I'm so excited to have you here. I've heard so much about you, and I can't wait to learn from you on the show. How you doing, and where are you calling in from?
John, thank you so much for having me. I'm super happy to be here as well. I'm calling from Seattle, Washington. Yeah. Really nice.
How's it going out there? Pandemic starting to go away? Things are opening up?
Absolutely. We're starting to see an adjustment in people's normal lives. So we're starting to see the normal things coming out. So restaurants are opening.
Nice.
The gyms are opening, no problem. Simply, a lot of people are taking the chances of getting vaccinated, doing the right thing, of course. So it's great to feel like you don't have to get so rigid with the rules. So I'm feeling a little bit more normal now. The bad side is more traffic now. So
yeah, exactly. That was one of the. There's definitely been a few great things about the pandemic. Like here in New York, especially in the beginning, like April 2020, I could run around, bike around anywhere I wanted. There was never any traffic. If you needed to get somewhere in a car, it happened instantly.
Exactly.
And now we're back to our 6 mile an hour.
Yeah.
Slog.
Yeah. Takes me 25 minutes to get to the office, and with traffic, you can triple that time easy. So
yep.
Yeah.
I've only been out to Seattle once, but I really enjoyed it. I was there for one night. I'd been skiing, and man, I can't even remember where I went skiing, but there was a huge snowstorm a couple of years ago, maybe a year before the pandemic. And wow, I can't believe I can't remember the mountain, but there's beautiful skiing out there in the Rockies. And it was about a 2-hour drive into Seattle, and I flew out of there. So stayed one night. I don't know. Didn't really see much of the city.
Yeah.
But it seems like a really nice place to live.
You're not alone, because when I showed up here, it was right in the middle of the pandemic. 2 weeks later, it was like, hey, everybody needs to stay home. Can't see anyone. So really, my training at work was remote, and I never had a chance to explore. So hopefully this year, we're gonna start by the end of this year and into next year, we'll get to explore a little bit more. So that's one thing I'm looking forward to.
Nice. So you moved out to Seattle to work at Amazon.
Yes.
And that's their biggest. That's their biggest office.
Main office in Seattle.
Mm-hmm. And so we'll talk a little bit about your work, but first I want to talk about how we know each other. So Harpreet Sahota, who was on episode 457, I kind of was aware of you through him because you show up in his happy hours. I haven't been to his happy hours, but he posts photos from there, and so I see your face. And so you've been on my radar for a little while. I was like, I can't wait to have the opportunity to talk to Greg and see if he wants to be on the Super Data Science podcast. And then you were at Data Science Go in April. So Data Science Go is the conference affiliate of the Super Data Science podcast. And I reached out to the Data Science Go organizers and I said, have you had any speakers recently that were absolutely amazing? Because I'd love to get them on the Super Data Science show. They recommended you. And I was like, great. I asked you right away because I was like, I've known about Greg for months. And now finally I get to have you on the show. You've also been on Harpreet's podcast, right? You've been on his Artists of Data Science podcast. You were talking about product management.
Yeah, that's right. It's such an honor, and I thank the Data Science Go team for this referral. I'm truly humbled by that, and who can miss Harpreet's happy hour? I can't wait to miss this, right? So I try my best to be there every Friday. It's such a very great environment to discuss data science for data science folks and non-data science folks. So it's very welcoming. So I truly appreciate being there and learning from everyone participating there. And thanks for finding me there too. So now I'm on the super data science.
Yeah, you're here. It's happening.
So yeah, that's great.
So you are a prolific content creator, and this is kind of, see you pop up, and then I see you just, I guess, as like a second degree connection on LinkedIn. Initially, I see tons of content because every day you're posting really valuable content. You post really great data science blog posts. You post academic papers and you write summaries of everything you post. But for academic papers in particular, it's really helpful because you bring home the main point of that paper. You post courses, you post textbooks, and people like it. So you've got 70,000 LinkedIn followers at the time of recording. By the time this is live, it's probably going to be way bigger. And you've been recognized for it. It isn't just the quantity of people. It isn't just me being the host of the show. You were recognized in 2020 as a LinkedIn top voice in data and artificial intelligence. So I don't know if you're going to have anything to say because I'm probably just embarrassing you.
Man,
But
I'm starting to feel my head get so big, but it might explode. So, but yeah, it's for me, when I especially research papers, for example, right? So they can be a pain to read, but I like the short ones. Short ones meaning 10 pages or less. And what I do, especially in the summary section of my post, is to provide somebody with much less time to kind of skim through and understand the content of the document, but also give people an idea of what my thought process is after reading the paper. And I'm also opening myself for somebody providing me an opinion that might be way different than what I'm expressing. So, and I'm aware that I could be totally wrong. And at the end of the day, you know, when I have comments from people after a post, I learn either way. So it's a great exercise, and one I hope I can take beyond just LinkedIn, because there are other channels also that can harbor this type of content that people can take advantage of.
nice. Well, yeah, I greatly appreciate what you're doing for the community. And of course, we'll have, like we do for all guests, we'll have links to your profile in the show notes. And at the end of the program, we'll talk about all the ways that people can stay in touch with you. I actually know with you, there's more ways than usual, including lots of opportunities to speak directly with you in any given week. So that's really exciting. People will have to hang around to hear about that.
Absolutely.
So we just talked about how you moved to Seattle in the pandemic, so relatively recently started working at Amazon, but you also had other roles. You've been working for years, working on kind of process engineering and optimization, right? So
Mhm.
at Lonza, at Avery Dennison, and you've formally educated in industrial engineering and engineering management. And I found out just before we started recording that it's kind of an interesting story as to how you ended up in the US. So you came over to study, but you kind of got stuck here.
Stuck in a good way, yeah, absolutely. And I say it's somewhat some sort of luck that came out of an unfortunate event. And when the earthquake happened in Haiti, I was about to end my master's degree. And whether bachelor's or master's, you have a certain period of time to stay to look for a job and have that hirer accept to sponsor a work visa for you. If you didn't
Right.
find anyone, that period expires, you would have to go back home. So, with that unfortunate event, the US government, which was the earthquake, the US government allowed us to stay leveraging a temporary work permit. And that's what I've used to kind of take some stress down, that stress of having that 6 month period of time to look for a job, to
Yeah.
taking my time to look for companies who will accept this temporary work permit to hire me. And that's how I got into the professional world, which I'm super grateful for.
Well, yeah, I mean, it's really great to have you here. Obviously, you're an enormous force in the data science community, and I mean, I guess that same, at least in terms of the content creation, I guess you could do that from anywhere in the world. But yeah, I mean, I think the U.S. is lucky to have you,
I
and it's really
appreciate
great.
that. Thank you so much.
So beyond your kind of day-to-day work, I understand that you do lots on the side. So you provide not only in content creation, not only in your day job at Amazon, but you also can help people out in other ways on the side. So do you want to tell us a bit about that?
Yeah, absolutely. So I talk to a lot of startups and to help them grow, help them identify use cases, help them identify product market fit and things like that. So providing some advising to startups is something that I like to do on the side. So I really make my time flexible. It's amazing when with proper planning inside of 24 hours how much things you can put out, right? So I try my best to leave a section here and there to help out, and I do have a plan in the near future, which is starting to reach out local universities with these incubators at university level to start offering my help there and start building a network and helping companies, especially AI focused startups, to help them kickstart and even channel them through funding as well. So I do have a list of contacts who can help with funding as well. Given that there's traction, there's a clear plan for growth. There's been some historical performance and things like that. Depending on what level these startups are, we can find some fundings for them.
Very cool.
Yeah.
So if somebody has an idea, a pitch deck that they've put together, they should just reach out to you?
They can, so it will be more of a let's launch it and let's get traction before we can talk about okay, let's try to get funding, because then you need to
Of
really
course.
walk a little bit, because it
Yeah.
depends on the people I talk to. Typically they want to see some traction, some growth and things like that, so before they kind
Yeah.
of bite the bullet and
People
things like that.
definitely want sales.
You have, yes, you
Uh,
have to have a team, you have to have the proper metrics, you have to understand the market and things like that, and start running, really, I mean, start walking before you start running.
nice. This episode is brought to you by Super Data Science. Yes, our online membership platform for transitioning into data science, and the namesake of the podcast itself. In the Super Data Science platform, we recently launched our new 99-day data scientist study plan, a cheat sheet with week-by-week instructions to get you started as a data scientist in as few as 15 weeks. Each week, you complete tasks in 4 categories. The first is Super Data Science courses to become familiar with the technical foundations of data science. The second is hands-on projects to fill up your portfolio and showcase your knowledge in your job applications. The third is a career toolkit with actions to help you stand out in your job hunting. And the fourth is additional curated resources such as articles, books, and podcasts to expand your learning and stay up to date. To devise this curriculum, we sat down with some of the best data scientists as well as many of our most successful students and came up with the ideal 99-day data scientist study plan to teach you everything you need to succeed, so you can skip the planning and simply focus on learning. We believe the program can be completed in 99 days, and we challenge you to do it. Are you ready? Go to superdatascience.com/challenge, download the 99-day study plan, and use it with your Super Data Science subscription to get started as a data scientist in under 100 days. And now, let's get back to this amazing episode. Well, that's really cool. So yeah, another way that you are contributing to everyone, to this entire economic ecosystem. It's brilliant. So not only through startups, but also through your professional work, I gather that you have a lot of experience in making the most of artificial intelligence. So you have a really great sense that you've honed over the years of how you can get a return on a commercial investment in an AI project. So do you want to talk a bit about that, or maybe kind of your top tips for other people getting a good return on their investment in AI?
Yeah, absolutely. So for me, AI, once you have people And let me try to make sure I understand the question. And you're talking about like some sort of best framework to get a return on AI investments, right?
Yeah, if you have something
Yeah.
like that, that would be amazing.
Yeah. So one thing I keep talking about, and I that really caught my eyes is this company called Element AI. They
Element AI, that's
Yeah.
Joshua Bengio's company in Montreal, right?
Yes. So
Yeah.
they built this AI maturity framework, which I think everybody should use. A lot of times people want to say, I can leverage AI to get myself to the next step. And then they start and then they get stuck. The first step to me to understand how AI can help you is one, realize it's a tool that can be used amongst different tools. It requires a mindset, a culture, mindset change, and culture that needs to start from the top. Now, another thing too is before you do anything, you have to be able to evaluate your maturity level. So, which I'm coming back to Element, which has this great framework. It's a 5x5 framework that you can check where you are on the maturity level. So whether you're exploring, you're experimenting, you're formatting or optimizing or transforming a section of your company or your whole org. And then you have those different section of your organization that you need to measure against that. You have strategy, technology, people, data, and governance. So once you understand this, then you need to understand how to separate the use cases. Sometimes we focus on the very short term deliverables, typically that are tied to money, which is let's quickly win more revenues by leveraging AI to better provide recommendations to our users. Or more long term strategic transformation of your business, which is more like how can I improve the user experience when they go to my website? How can I, improve the customer service experience once we start kickstarting this process and things like that? So those are the more long-term transformational things. Once you understand these use cases, you can understand how to go about it with that framework. I think it's one of the best that I've seen out there.
Nice. That is a very specific framework that will really help people out. Now, I just realized that so we were going to get to audience questions later, but I think we've actually answered one of the audience people's questions already. So Bernard Tumanjong, whose last name I'm surely mispronouncing, who's a software engineer and machine learning engineer, he reached out to ask you on the podcast what framework should organizations consider to formulate a stable, enduring, long-term AI vision. And I'm pretty sure you just nailed it.
Yeah. I think I remember seeing something like that. In to me, it's the best one. And this is the first step, in my opinion, to understand what kind of return on investment you want to have. And you have to really learn how to even crawl, right? Before you get to project execution and things like that. So, absolutely.
Nice. All right, so let's go right into the audience questions. So we had Bernard's there already. The next one is from Serge Massis, who is someone that I've known for years. He was the MC at a talk that I gave at an open data science conference back when conferences were still in person. And he's the author of Interpretable Machine Learning.
Mm-hmm.
He has a great question for you that is relevant to his background, but I think will be relevant to a lot of listeners as well, which is that Serge is a startup founder. And so he's interested to know from you, based on your experience advising AI startups, what data science skills or attitude is most needed to succeed with an AI startup.
Yeah, I like that question, and I think the attitude, especially even skills, we can put all of the professional skills in the box and still apply those. They're very helpful. We all know them, the kind of skills that a good data science needs. But when it comes to startup, I think in terms of attitude, you have to be able to understand what it takes to move slow and move fast, right? So when it comes to a startup, just like any other company, you have to have a vision, a mission, a strategy that explains how you will go about that vision and mission, and also your tactics. So, as a data scientist, you have to be good at all of those, understanding the long term strategy and also understanding what kind of tactics are available to you or you can use to reach this long term or to execute this long term strategy. And being quick in the tactics helps you iterate fast, help you try different things, and which is the core of a data scientist, right? They try, they're explorers, they find things, they discover, they try, they confirm things. So being quick on these tactics is what will get you above water as a startup up to future success.
Nice. That's a great answer. And I guess with that iterating tactically, that's to solve both your machine learning problems as well as your business problems, right?
Correct. It doesn't change. It is the same thing as we were saying on AI startup or non-AI startup. It's the same thing. From a business perspective, you want to be quickly iterating because you want to be faster at that point.
Nice. All right. Well, that was a really clear answer. Thank you for that, Greg. So next one is from Kenneth McCabe, who is a data analyst and also an MBA candidate. And so Kenneth is wondering what data science methodologies and models you've used most in your career. So I guess, which ones have been most useful to you?
Yeah, mostly in my career, I've seen classifications, so supervised models. Is it a cat or a dog? So just being very high level here. One of my past companies were leveraging a computer vision to determine whether the product was good or bad, and the product was flying on a conveyor belt at high speed. So really, classification is really so labeled data was a leverage. Hopefully, over the next couple of years, I'd venture a little bit more about on unsupervised models. But it could be even an NLP perform different tasks there as well. So it could be something like summarization or translation, name entity recognition. Those are the different things that I've seen so far.
Nice, very cool. Thank you for that one, and we definitely have time for a couple more here. So here's a good one from Nikolai Kurbutov, who is an AI project manager as well as a data scientist. Nikolai is based in Russia, and he's engaged with me a lot on the podcast. He always has great questions. So he asks, what is the most common thing that you've experienced in terms of trade-offs for ML models pushed to production? So in most cases, we have to choose between quality and speed. But he's also interested if there are any particular trade-offs related to implementation.
Yeah, that's an awesome question. I really like that one. And the most common that I've seen is trade-offs in terms of risk. Typically, we want to leverage AI to remove the human factor. And whether it's human or machine, there's always room for error. And sometimes you will have a trade off between systems where humans tend to be a little bit more accurate but slower versus a machine, which is faster and a little bit less accurate, and try to understand what are the risks of that lower accuracy. So being able to translate that into a business risk is the trade-off that you like to talk about with your stakeholders. If machine predicted wrong, what is the risk to the business? And can the business support it? And most importantly, how can the business mitigate when that error shows up? What are the processes? What are the tools? Who's responsible for capturing this error? Who's responsible for addressing it? And who's responsible for continuously training these models to make sure that these errors don't increase or improve over time?
Right. What a great answer. I Oh, well, I don't know what I was expecting, but I wasn't expecting that. And that was a great answer. I love that.
Yeah.
And so I guess one of the things that people could be thinking about specifically, perhaps following on from what you said, is when they're retraining their models or having the models in production, to have systems in place to be looking out for feature drift, to be looking out for inputs changing beyond the range of inputs that we saw in training the model.
Yeah, absolutely. And even prior to deploying, you want to have alignment with business side as well. All parties involved in terms of what is the expected error rate would be. So, say for example, your precision threshold might be no more than 2%, right? Because you really care about precision for your use case, and
Right.
you want to make sure you stay within there. But even aligning on that 2% is important because prior to automation, you had a higher precision or a lower
Right.
threshold, right? Because of humans
Right.
who are doing it, they were doing it
Yeah.
slower, they were doing it with more accuracy and things like that. So therefore, now you're moving to a machine which has a little bit more room to make errors. And how do you make people align on this? That when the
Right.
machine will make more errors because it's faster, that trade off, how do you mitigate these errors? What does it mean in terms of loss of business when
Yeah.
you
Right.
move, precision threshold from 1% to 2%? Maybe a small
Yeah.
number, but it's a huge risk for a big business.
Right. So if we like kind of just play around with some numbers here. So if you had a 1% error rate when humans were completely in charge of this process, so like 1 in 100 customers complains.
Mm-hmm.
But now all of a sudden with this automated process, it's faster. It's probably less expensive than having humans, but it has this error rate of 2 in 100 or 1 in 50.
Mm-hmm.
So we're doubling our error rate, and so we're going to have twice as many complaints to our customer service center. What impact is that going to have? Or we're going to have twice as many returns.
Mm-hmm.
And so there's this business needs to be prepared, and you need to make sure that you've costed out those risks, I guess, right?
Exactly. Have the right processes to mitigate those things when they show up. It's all about downstream actions when it comes to leveraging ML, AI tools, and things like that. What are you doing with that prediction downstream, and how does it really make your business better overall? That's what this is about.
Nice. Love that answer. All right. We've got one last audience question here. It's from Yusuf Rabi,
Yeah.
or Robbie. It's probably Yusuf Rabi. And he's a machine learning researcher.
Mhm.
So he asks, other than data improvements in terms of quality and quantity, what provides the biggest bang for the buck in terms of improvements for an AI vision system? So he's very interested. I guess he's aware of your experience with machine vision projects. And yeah.
Yeah, so this question is quite interesting because he did hit the best bang for the buck, right? You're talking about a computer vision system, and you're already feeding it quality images and things like that. I think the next bang for your buck is taking a look at the whole cost of ownership of your system. Right? Can you improve on computation power? Right? Are you spending too much? Do you have opportunities to use less computation, use a better model that helps you compute less. Overall infrastructure, can you improve integration of systems to lower the cost of maintaining it? And then you can improve on monitoring, right? So, how are you making sure that this computer vision system is sustainable? Can be upgraded very fast? Does it have a monitoring bank of data that's continuously looked at to make sure that this data is used to make it better or train a different model? Is there a really great MLOps mechanism to maintain that system? Really, that's the only thing I can see, because once you have great data, I don't see what else. Can there be additional data that you can collect Because
Even more.
yeah, because at some point you will find that you have quality data and you're stuck at a certain accuracy level that you cannot go past because you can't improve on the data anymore. Well, what other data can you go out there and grab and label and feed into this model to make it better? So additional data collection is another way to look at it. So I see three: monitoring mechanism, additional data collection, and improving the total cost of ownership. So those are the three areas that you can take a look at.
Nice. A wonderful answer. I mean, you have great answers to all of these questions,
Appreciate it.
which leads me to my kind of big series of questions. So, in researching for this show, I discovered that you're developing quite a bit of an interest in quantum machine learning. So I've seen you posting about it a lot. I see that you have a certificate from IBM on quantum computing. And so I think it's a fascinating topic, and I'd love to pick your brain about it. So I guess, first of all, what is quantum computing? How is it different from traditional computing?
Yeah, so I will attempt to answer this as Greg Coquillo trying to understand this complex world of science, and the curious Greg Coquillo and me who will try to help everyone else listening to this understand. So I guess quantum computing is the idea of exploring the world of quantum mechanics and leveraging these characteristics to build a computer that does just that, compute, compared to a classical computer. When compared to a classical computer is equipped with bits who can be either 0 or 1. However, a quantum bit, which is for short qubit, can be both 0 and 1 through a phenomenon called superposition.
Oh,
This is something that allows quantum computing through the manufacture of quantum circuits, which are gates that allows you to perform certain instructions called algorithms, to compute them faster than normal because you have two states at the same time. So you
right.
can reduce computational power by millions, right? So it depends on how complex the most complex factorizations or the most complex search algorithms and things like that can be performed much faster with quantum computing. And the last thing I'd like to say is with quantum computing, which is still, even though we've been working at it for so long, seemingly, it's still at its infancy. Still, no one knows what will come out of it at the end, because it's a very noisy environment. We just don't know how things will come through. But in the end, what you will find is that there will be just another way to compute on top of what you already know: CPU, GPU, TPU. Now you can start expecting QPU, and
I
they
see.
can be focusing on specific use cases that may want much powerful computational powers, and we can talk about different industries that can leverage these. So drug development, biology to synthesize new materials, material science, very complex things, very complex use cases that requires simulations for airplane makers and things like that, that require huge amount of data, huge amount of combinations to simulate the right way to perform something. Quantum computing can be helpful there.
Cool. I did not know. I just hadn't it hadn't occurred to me, and I'm never going to forget. You just pointed out something to me that now is so obvious, that QPUs, these quantum processing units, which are, as you say, in their infancy today, these will be appended to a classical computing system. So you'll have that CPU still running the operating system on the computer and letting you look things up in Stack Overflow. But in the same way that today, for training a deep learning model or maybe even production with a very big machine vision model, we will have particular operations sent off to the GPU to run on that specialized processing device. So in the same way, there's going to be a relatively small number or narrow set of tasks that we say, okay, this is perfect for a quantum processing unit, and we send it over there, and then we get the returned the results back.
That's correct. I do believe there will be something like that for sure, and also I'm not eliminating the fact that we may also see a quantum computer on a circuit board, right? So just like we saw with the transistors, we want to make sure we build systems with millions of qubits. I think right now the biggest system that claimed quantum supremacy has 76 qubits only.
Right.
So when you compare that with a chip for a classical computer that has millions of transistors, we're way out from that achievement, but we believe that it can be done. So you'll see that at some point as well.
Cool. So in machine learning in particular, I guess maybe you already did give some examples of potential applications like creating materials. I guess we could be doing that in kind of a machine learning driven way. Is that when you were going through those examples? I guess those were like kinds of those were machine learning.
Yeah, exactly. They can be seen as machine learning, but then again, you can leverage quantum to build a quantum neural net, right? That adjusts the weights faster with less data, things like that.
Right.
You could leverage it to build a classification model. In my particular one, which is optimization use cases. So the most complex flight systems or flight scheduling systems can leverage quantum computers with as a hybrid with a classical computer to optimize weights for a neural network that is used to predict flight schedules or something like that. So this is where the hybrid quantum and classical can come in very handy. One of the fallbacks or for quantum computer is it's not as precise as classical computers. It's good at giving you a probability range, a probability that this is it. But in terms of saying this is it for sure, the classical computer is better. So in terms of leveraging both as a hybrid system, you can get bigger bang for your buck. And this is where I believe a lot of companies are going towards, which is leveraging a hybrid system of quantum and classical to tackle the problems now instead of waiting 5-10 years down the road to say, oh, quantum is ready for you now to use. People are getting really smart building custom systems with these two to tackle today's problems.
Super cool. Well, I've learned a ton from that answer, Greg, so I'm really glad that I asked it. I'm glad that I stumbled across this developing interest of yours.
Yeah.
So do you have any particular recommendations of tools or resources for people to learn about quantum computing or maybe even quantum machine learning themselves?
Penny Lane, Quantum Machine
Penny
Learning.
Lane.
Penny Lane
Yeah, I've come across that.
It's a good one. I would say IBM Qiskit is another one that I can refer anybody who wants to.
How do you spell that? Qiskit?
Qiskit, Qiskit.
All right.
Yeah.
I'm glad I have you pronouncing that for me. Nice. Qiskit. Sweet. All right. Well, I'm going to check those out right after the show.
Yeah.
So all of this, I get you on the Super Data Science show. You think you're doing something for the audience, but really all of this was just for me.
Man, you're the mastermind behind this, huh?
Well, because I'm giving a talk on September 10th, an intro. It's just a 20-minute talk, but it's an intro to quantum machine learning. I'm giving it at the Machine Learning Conference, which is going to be in person in New York City at this cool nightclub called 230 Fifth Avenue. It's there all day. It's not like a party in the evening, but they've rented out the nightclub from like 8 a.m. to 6 p.m.
Wow.
and doing this 20-minute talk on intro to quantum machine learning, and I don't know anything about it. Almost everything I know, I just learned from you.
You will not be, you will not regret visiting Penny Lane for sure.
Nice.
You'll find what you need to know.
That was actually, it was stumbling across Penny Lane that led me to think, you know what? It looks so well explained here. I bet I could do a talk on this. And then I submitted the talk. And when they accepted it, I was like, oh no.
Now you're fully stressed. Now you truly need to rely on Penny Lane. So yeah. Absolutely. Absolutely. So, let me know if you need help with that too. So I'm happy to,
Yeah, I may need to fly you in.
No, from a preparation standpoint, for sure.
Awesome. Yeah, I would definitely appreciate your feedback on that. Okay, sweet. So, all right, you've answered so many great questions from me and from the audience. We've got to learn a bit about your background as well. Do you have any books, a book recommendation for us?
Yeah. So there's one that I'm reading right now that I've been very slow, digesting it. It's called Algorithms to Live By. By Brian Christian and Tom Griffiths. And it's really an exploration on how computer algorithms can be applied to our everyday lives. And it can help you solve common decision-making problems. So I'll give you one quick thing. This book has helped me understand the process of caching better than anything else. And it leveraged the use case of a library that stores recently rented books in a bin at the entrance of the library versus putting it back in its place, because these recently rented books most likely are the most popular ones, and they felt like people could just use them fast as possible instead of having to walk in the back into the sections of the library to look for it. So they cached it at the front desk for people to retrieve as fast as possible. So, which is an idea of caching in computer. So that was a cool thing to see, that what computers do, we do it on a daily lives and on a daily decision making. And, it's amazing that we're able as a human species to be creative enough to teach a machine to do what we do on a daily basis. So I think that was fascinating. So anybody can enjoy this book.
And caching can be hugely useful in machine learning. So with my company, we have this very computationally expensive process for taking natural language documents and converting them into this vector representation. So this one-dimensional vector of numbers. And that process, if we were to try to run that every single time we ran our models to make a prediction, it would take like days. You'd be sitting at your computer, you'd make a query and you'd have to wait days to get a result. But we can cache those vectors and have them readily available. And then so we can give you results in an instant as opposed to in days. And so, so this caching idea, the library book analogy, can be hugely, if people aren't aware of caching, I definitely recommend learning about it, either from the Algorithms to Live By book, or more generally, because it can be a game changer for productionization of your models.
Absolutely. Absolutely.
Nice. All right, Greg, we're reaching the end of the program, but I promised at the beginning of the show that people would be left with opportunities to get in touch with you in real time. So what are the best ways? Obviously, we've got your LinkedIn. I've already mentioned that. So people should follow Greg on LinkedIn. That'll be in the show notes where his profile is if you want to follow him. And in addition to that, where can people find you?
Yeah, absolutely. So if you want to catch me live, you'll find me definitely every Friday around 2:30 Central Time, I believe, at the Happy Hour, Data Science Happy Hour, hosted by the one and only Harpreet Sahoda. That's on Fridays. Then if you want to catch me on Saturdays, they're Saturdays around 9 a.m. PST. Sorry for giving you time zones all over the place. but this is with my family, the integrated machine learning, led by Dr. Tom Ives in Life Santari. Yeah, so
I know who he is. I haven't met him yet in person, but we've definitely talked.
You need to talk to him too.
Yeah?
Yeah.
All right. You should get him on the show?
You should get him on the show.
But
yeah, I think this is where anybody can find me live, and happy to talk to anyone. But also feel free to reach out to me on LinkedIn. It's fairly manageable. It's been a little bit more challenging lately because of the flood of messages, and LinkedIn is not the best UI to manage messages, but I'll try my best to respond to you at some point. So.
Nice. Well, that's super kind, Greg. I can't believe how much you give to the community, but it's certainly paying off in terms of how many followers you have and the LinkedIn Top Voice Award. So, just
Thank you.
Keep on trucking, Greg. So excited to watch how your career continues to develop and the huge impact that you make on people's lives. And hopefully we'll have the opportunity at some point in the future to have you back on the show and catch up with you.
John, I'd be happy to return, but thank you so much for having me for the first time ever. It's an honor. It's a humbling experience, and I'm looking forward to hearing more. But also, most importantly, I'm looking forward to seeing you grow with this great podcast of yours. So thank you so much.
Thank you, Greg. All right. Catch you in a bit. I love how clearly and succinctly Greg answered all the questions I and the audience had for him. When we were planning the episode, I thought we had way too many topics to cover, but Greg pops in with a spot-on answer, backed up with a straightforward example, and boom, we're on to the next one. In today's episode, Greg filled us in on Element AI's maturity framework for AI businesses, that AI startup success comes from understanding your long-term business strategy while iterating tactically to solve both machine learning problems and commercial problems, that while machines typically are much faster than people, they tend to be less accurate. So when automating a business process, you need to be sure the business is prepared to mitigate, capture, or address the risks from this. That while quantum machine learning is in its infancy, some optimization problems like flight schedule prediction are likely to be revolutionized by quantum processing units in the years to come. In particular, Greg pointed us in the direction of Penny Lane and IBM's Qiskit for getting started with quantum machine learning ourselves. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, and the URL for Greg's award-winning LinkedIn profile, as well as my own social media profiles, at superdatascience.com/495. That's superdatascience.com/495. If you enjoyed this episode, I'd of course greatly appreciate it if you left a review on your favorite podcasting app or on the Super Data Science YouTube channel, where we have a video version of this episode. To let me know your thoughts on the episode directly, please do feel welcome to add me on LinkedIn or Twitter and then tag me in a post to let me know your thoughts on this episode. Your feedback is invaluable for figuring out what topics we should cover next. All right, thanks to Ivana, Jaime, Mario, and JP on the Super Data Science team for managing and producing another amazing episode today. Keep on rocking it out there, folks, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.